All right, we are continuing this super fun chapter on circles. Today we are looking at arcs of a circle. So the way you make an arc is you get 2 points on your circle, and instead of connecting them with a chord through the circle, you follow the path along the circle, and that is what makes your arc. Now, if you were to draw to your center from the points on the arc, that would form what we call a central angle. And so the way that we measure arcs is in the same measure as that central angle that it intercepts. So it's measured in degrees. So if the central angle was 60 degrees, the measure of arc AB would also be 60 degrees. And then a few more vocab things. When we have an arc that's less than 180, we call it a minor arc. If we have an arc that's greater than 180, it is a major arc. And if we have an arc equal to 180, it is a semicircle. And then so briefly to talk about congruent arcs, we have a couple ways to know if arcs are congruent. If they are on the same circle and have the same measure, like in this picture, both of these arcs, AB and CD, are on circle O, and they both have a measure of 60 degrees. Those arcs would be congruent. Another way would be if you have two arcs with the same measure that are on congruent circles. So if circle P and circle Q have the same radius, then they are congruent. And then because arcs EF and EG have the same measure, these arcs would also be congruent. And then these diagrams are kind of off, but if your arcs intercept congruent chords, like what is shown in this picture, these chords are congruent in the same circle again, then your arcs are also congruent. If they intercept congruent arcs or congruent central angles, like here, or again, congruent central angles. So these are the 4 ways you can show that arcs are congruent. Oops, excuse me, my camera. Let's get into some practice problems. If I have that the measure of arc AB is 20 degrees and I want to find the measure of arc ACB, the remaining part of my circle, well, I know all the angles add up to 360, so I'm going to simply subtract 20 from 360 and get 340. So that would make arc ACB a major arc. Then on 2, I know that, and this should be angle XQY, not arc. If angle XQY is 110, that means that arc XY is also 110. So if I want to find the measure of arc XDY, again, I'm going to take 360 and subtract 110 to get my remaining measure as 250 degrees. So this would also be a major arc. Moving on to the back, I've got 2 concentric circles with center O. Concentric means 2 circles have the same center, but they are different sizes. And then I'm told that angle BOC is acute, which again, remembering from very early on in the year, that means that this angle is less than 90. So I'm going to follow these 5 prompts based on this picture. Name a major arc of the smaller circle. So in my smaller circle, I need an arc that's less than 180. Well, here, P to R would be a semicircle, so the other 2 arcs along there, PQ or QR, would both be, oh, excuse me, those are both minor arcs. I got this backwards. We want a major arc of the smaller circle. My apologies. Again, I want it to be greater than 180. So I know this semicircle here is going to be equal to 180, so I need an arc that's larger than that. So if I went from Q to P to R, that would be more than a semicircle, so I could have arc QPR, or I could go Q to R to P, and that would also be a major arc. To find a minor arc of the larger circle, again, here A to C is a semicircle, so those other 2, AB or BC, will both be minor arcs. Okay, what is the measure of arc BC here plus the measure of arc PQ? Well, together, those are part of what will be making a semicircle, which means they are going to add up to 180 degrees. Then which one is greater, the measure of arc BC or PQ? Well, I know that this angle BOC is acute, which means angle AOB has to be obtuse. So that means PQ is going to be larger. And then lastly, is arc BC congruent to arc QR? Now, these two arcs would have the same measure because they're intercepting the same central angle. However, they are not on congruent circles. The inner circle is going to be smaller than the outer circle. So no, they are not congruent because they are not on congruent circles. Okay, moving on to example 4, I've got this new diagram here. We want to find the measure of arc BC. So arc BC is here, and it's intercepting this central angle where I have a right angle tick mark. So that tells me that this is going to be 90 degrees. The next one wants me to find the measure of arc AD. So this one we know is labeled 50. These both have right angles, so we know those are each 90. So to find AD, I'm going to take 360 and subtract 50 and 90 and 90, and that is going to give me 230 degrees. Oops. Sorry, not 230. 130 degrees. Got ahead of myself here. Okay, so then to find the measure of arc ACD from here to here, I'm going to add 50 plus 90 plus 90, and that will give me 230 degrees. For the measure of arc BAD, that's going to be 50 plus, we already knew this one was 130, so those two together add up to 180. And then lastly, I want to find the measure of arc ADC, so that's going to be 130 plus 90 for a total of 220 degrees. And then now, just to test your knowledge on minor, major arcs and semicircles, let's go through and identify each of those. This will be a minor arc because it's less than 180. Also a minor arc because it's less than 180. Major because it's greater than 180. Semicircle because it's equal to 180. And major because it is greater than 180. Okay, the last thing we're going to talk about here is some stuff to do with area and circumference of circles. Here are those two formulas in case you have forgotten. But on this first set, we're going to find the area and circumference of each circle with the following dimensions. So for this one, if I know the radius is 5, my area is going to be pi times that radius squared, which will be 25 pi. And we're just going to leave pi in our answer here. Then to find the circumference, first I could say, okay, I know this diameter is going to be 10. So I could say my circumference is going to be the diameter times pi, so 10 pi, or 2 times my radius, pi, which will still give me 10 pi. On the next one, my diameter is 12, which means my radius is 6. So to find my area, that's going to be pi times 6 squared, which is 36 pi. And my circumference, again, I could just use my diameter and know that it's 12 pi, or 2 times my radius, pi, will still give me 12 pi. All right, on the second set, we want to find the radius and diameter of a circle with the following dimensions. So if the area is 36 pi, that means that 36 pi is equal to pi times the radius squared. Well, I can divide pi so that these will cancel. And if 36 is equal to r squared, and I take the square root of both sides, I now know that my radius is 6, which means my diameter is going to be double that. On the next one, I'm told the circumference is 40 pi. So if the circumference is 40 pi, that means that 40 pi is equal to 2 times the radius times pi. So again, I can divide out those pi's, and if 40 is equal to 2 times the radius, if I divide by 2, I get that my radius is 20, which means my diameter is going to be 40. And then the last little tidbit we're going to talk about is, what is the result when you divide the circumference of a circle by its diameter? Well, let's look at all of these examples we have here. On this first one, my circumference was 10 pi, and my diameter was 10. If I divide those, I'm left with just pi. Okay, let's look at another example. Here, the circumference was 12 pi, and my diameter was 12. That leaves me with pi again. Let's do one more just to see if the pattern sticks. On this last one, my circumference was 40 pi, and my diameter was 40. And what do you know? Again, I get pi. So what this tells me is the ratio of the circumference to the diameter of any circle will always be pi. And this concludes our notes from section 10.3.